Hey everyone, today in this video I'm excited to be taking a look at the MSI. This is their MEG Ai1600T PCIE5 power supply. This is a 1600 watt power supply that's 80 plus titanium rated. MSI did send me this unit, but any opinion expressed in this video is strictly my own. That being said, if you're interested in this product or you want to find out more about it, the link to it will be in the video description. Take a look at the retail box and packaging. You'll be hard pressed to find a better presentation for a power supply than the packaging that you see here. It's super premium, high-end, and top of the line, which we would expect with this series of MSI power supplies. Now let's go ahead, let's open it up and see what's inside. Here are all the contents. First up, we have some product literature. This piece will allow us to request our power supply testing report, which is really neat. Moving on, we have our hardware kit here with 4 screws for mounting this and getting it installed. Multiple cable management ties here, really high-end ones with MSI's branding and their Velcro. They're reusable, not just your typical zip ties. Then we have our bag O cables. We'll dump this out and look at all the cables here in a second. And then last but not least, we have the power supply unit itself. Let's take a look at the cables and the unit in more detail. Tons of cables are included. We'll start with the main power cable here from the wall to the unit, and look at how large and thick this is. That's amazing. Super impressive. 2 Molex cables, 2 CPU cables, 7 PCIe cables, 2 SATA cables, 1 USB Type-C cable here, main motherboard cable, we have 2 of our 12-volt high power cables here. I love the yellow tip ends, so we know if they're properly seated and plugged in to our GPU. Both rated 600 watts. Yellow tips is always a nice touch. Now let's look at the power supply. Starting with the back side of the power supply first, we have a sticker that we can remove that explains the 0 fan mode for us. Maybe you can read that from there, maybe not, but basically, if you toggle this switch on or off to enable 0 fan mode, under low loads, the fan will not be running. So you can pick and choose if you want that. I love the physical control. Then we have our on and off switch there. Here's our plug, and we have MSI's logo and branding. Here's your first side profile. We have MSI Enthusiast Gaming down here with their branding. Nice color accent. And we can peel this off. Here's a look at the other side. Same branding down at the bottom. Now we got MEG up at the top. Looking at this side, down towards the bottom, we have our product specs for the power supply unit and the 80 plus titanium rating there. Flipping it over to the other side, this is one of the nicest fan grills and designs that I've seen. Love the gold accents here. We have their logo with a little bit of plastic protective that we can remove as well. And then here's a look at the last side with all of our connection options here. Everything's clearly labeled for us. Very easy to see and make sure we have everything properly connected where it should go. Take note here too, what makes this one special. We have our 2 12-volt high power ports, and we have a USB Type-C port right there. Before going any further, let's address a common question that we get. A lot of times you'll ask, will this work with my GPU and CPU? So I went ahead, I threw together a chart that shows you the NVIDIA GPUs and the recommended wattage that they need. And we did the same thing for some popular AMD GPUs as well. Keep in mind, this is just for your GPU, so it'd be best to add an extra 100 or 150 watts for your CPU, depending on if you're using like an entry-level or mid-range CPU, or if you're using a top-of-the-line flagship CPU. But anyways, here's a look at NVIDIA GPUs first. From 550 watts all the way up to 1000 watts. You should be able to find your model anywhere from the 3050 up to the 5090. And moving along to the AMD GPU side of things, 650 watts all the way up to 850 watts. And same thing, don't forget to add in an extra 100 to 150 watts for your CPU, whether that's Intel or AMD. Before installing it in our test bench, I thought I'd go ahead and just power it on here so we could see if it gives us the proper voltages and measurements that it should right out of the box. So first up, we're going to boot it. Blue is what we want to see here. 5 to 5, 11.8 to 12, 3.2 to 3.3, 11.8 to 12, 5 to 5, and a PG score of 200 milliseconds. We want that to be between 100 and 500. So far, so good. That's going to be for our main motherboard cable there. Let's move along to our next one. PCIe right here, 11.8 to 12. Great. Blue is good. CPU 11.8 to 12. Blue is good. And then we have our SATA 5 to 5, 11.8 to 12, and 3.2 to 3.3. Blue all around there. So it passed our initial test. Let's go ahead, let's get this installed. Really quick, for those that haven't installed a power supply, let me try to show you exactly what we're doing here so this will make sense. At a minimum with your build, you'll be plugging in one of these cables. That's the 12 volt high power, assuming you're using like a 3000, a 4000, or 5000 series GPU, or some of the latest from AMD as well. So that'd be for your GPU cable for your power there. If not, you might need to connect a couple of these PCIe cables depending on your GPU and the connector type. So that's the first thing, your GPU. So plug one here. We're going to plug this end into our GPU. Next, for our CPU on our motherboard, we'll need two of the CPU cables. So you'll plug them in any of the open CPU PCIe slots. Again, everything is clearly labeled for you. And the CPU end will be the end that you plug into the motherboard. So it's clearly labeled, so you know exactly what you're getting into. And then lastly for us, we have our motherboard cable right here. So it splits to two that you plug into the power supply, and then the one solid piece will plug into your motherboard. So you'll always have motherboard power, you'll always have CPU power, and you'll always have GPU power. You might plug in some SATA or something else depending on your configuration if you're adding like 2.5 inch or 3.5 inch drives, hubs, controllers, any of that right there too. And in this case, we'll also plug in our USB Type-C cable into this spot, just like that. And here's a look at everything plugged in at the test bench. First, we're starting with the GPU. Notice how we don't have any yellow visible, so we know that it's seated properly in our graphics card. Here's a look at that motherboard cable plugged in, both CPU cables plugged in. And if you can see on the side, there's the little CPU labeling on the cable that's still visible. And then although it's USB-C that connects to the power supply, it just uses your regular USB header here. It doesn't actually use your USB Type-C header on your motherboard, so just keep that in mind. So it can plug into any of the open USB ports that you have. And on your motherboard, it might actually say USB like this one does here, but you can just line it up and connect it to any of those that are available. The PC's powered on and we're right at the plug here, so I wanted to put a meter on it so we could see. Currently getting about 60 watts, 0.6 kilowatt hours, 123 volts, 0.5 amps. There's our low wattage, 59, and our high was 891. But we're sitting at 62 right now. With everything powered on, I can show you really quickly how the zero fan mode works. Since we don't have anything under load here, the fan is currently spinning because we have zero fan mode off. Watch what happens to the fan when I toggle it on. The fan has stopped spinning, so once it goes under a heavier load, then the fan will spin up. But if it's not under load, it'll just keep the fan off like you see here. If you don't like that for whatever reason, and at this point, the fan spinning just at idle isn't loud. I really can't hear. I can still hear the pump from this more than I can hear anything from this fan. You have the option to still leave it on. It's not like it's really loud or obnoxious, just spinning at low speeds. Moving right along, I wanted to show you MSI Center with our power supply connected. So currently under the Features tab, you can select the power supply unit and take a look at that. We have real-time results right here with the power supply, current wattage, efficiency, temperature. So we are trying to stress it right now with our GPU and CPU. We'll let it run for a while and then check back on the results. But you can see what we're getting in real time right here. And we can select this, and here's the dashboard that starts to build. Everything charted for you. You can screenshot or save as a CSV. But with that USB Type-C cable connected to our USB header, this is the access that we get for those that want to monitor this in real time. You can do that right there, which is pretty cool. And everything right at your fingertips right here. Moving on to our stress test, it's been over half an hour with this power supply running, maxing out our CPU and GPU. On our test bench, we have the NVIDIA. This is the RTX 3080 FE, and we have an Intel 13900K CPU. We're using about 800 watts, give or take a little bit right there. with this running without any hiccups or issues at all for the last half an hour. I wish we had even more juice to throw at it since this capacity is so large. 1600 watts, we're not even using half of it right here with our Intel CPU and our 3080 GPU. So plenty of headroom for whatever sort of massive power hungry build you're going to be using, especially if you're pushing that build to the limits with everything running at 100%. Good news here, everything is working as it should. Diving into that in a little bit more detail, looking at MSI Center here, current wattage, efficiency, temperature, 33 degrees Celsius. We can look at our test. So for the voltage right now, 1.29 volts, 371 watts for the CPU. And then for the GPU, 0.775 volts and 319 watts for the GPU right there. But it's really cool that in real time, we can monitor this power supply through MSI Center if you want to connect that USB cable. With everything under load, we're back at the source to see what we're getting. 816 watts, 0.68 kilowatt hours, 119.7 volts, 6.8 amps, 59 is still our low, and 891 is our high. And then we're back to where we began from. It's always a good day when you can get out the FLIR cam. So starting with the GPU cable right here, take a look. About that 150 degree range there. And then cooling off further away from the source that we get. Then looking at the motherboard cable here, call it 90 degrees Fahrenheit. Looking good, nice and cool. And making our way to the two CPU cables, right around 100 degrees. A little bit more, a little bit less. For both of those. But look at how hot the heat sink is on the board, though. A lot hotter there. Some hot spots down below. Really getting toasty. And then looking at the power supply itself. Back cable's good, 80 degrees. Got a hot spot inside there through the mesh if we can get some of that. 115, that appears to be the hottest spot here. Try to go look in the fan. We got another hot spot in there. Here's a look at the side. 92. A little bit cooler on the other side here. Mid-80s. And then looking at the back side. Up at the top's our two CPU cables. Down below's our motherboard cable. Looks hotter than it is on the FLIR. And then this side, our GPU cable right there. USB-C. Pretty cool. Really quick, I wanted to show you the beautiful RGB on this power supply. It looks so nice with a glimpse into our little window here with the light glowing and the design and pattern on the inside with the MEG. It's really a nice, subtle touch to this power supply. So where does that leave us in regards to this MSI power supply? Well, so far, so good. And with the 12-year warranty, you can buy a power supply like this with confidence. It has all of the latest and greatest features jam-packed into this unit, giving you plenty of connection options and plenty of juice, regardless of what GPU or CPU combination you're going to throw at it. You'll have plenty of headroom for future expansion.